Welcome to this presentation. My name is Diewoke and I will explain the first part of the slides. We will shortly explain the idea of Snacksense, which is about the innovative design of food structures for enhanced sensory reward from healthy snacking. To explain the concept of this project in a nutshell, we want to understand all the steps from food structure to oral processing, to flavor perception, to food liking, and to food intake. And this team consists of researchers working in the field of food technology and food formulation, as well as sensory science and eating behavior. Snacking greatly contributes to our daily energy intake. In the Netherlands, it's estimated that 30% of the daily caloric intake is due to snacking, and for overweight or obese people, this is even more. We have strong innate preferences for sweet and fat, for example, or a combination of salt or savory and fat. And all these kinds of snacks are very high in energy density. So the question is, how can we design food structure that moderate intake without compromising on consumers' acceptance and reward? Many snack foods can be consumed at a fast eating rate, and if they are also high in energy density, this can easily lead to overconsumption. Especially the combination of both is a strong predictor of energy intake. There is a lot of evidence that the energy intake rate is related to energy intake, but also to weight gain and development of obesity. So if we want to decrease the energy intake of snacking, we should either work on the food texture that is very closely related with the eating rate, or the energy density. And the most powerful is, of course, working on the combination of both. On the right, I show a figure that I published a few years ago that summarized all the effects of texture properties on oral processing and food intake. The words with the black arrow means enough evidence, and the gray arrow means it's based on hypothesis or there were only limited results. So we know that food structure or texture has a key role in eating rate, food intake, and satiety. There's enough evidence. So we could design foods that will be consumed slower, but the real challenge is to design foods that also extend the flavor perception and the liking. So therefore, we first need to have a clear understanding of the relationship between the food structure, flavor release, and liking to design these healthy snacks. Now my colleague Stefano will take over to explain a few slides about food texture design.
To design innovative food for controlling energy intake while optimizing sensory perception, we have several tools available. First of all, we can play with the texture by making smart choices in the design of formulation and processing conditions. Next, we can play with the morphology and the dimensions of the food. And last but not least, we can play with the distribution of components when we are working with composite foods. And composite foods are very often what we consume. So all these three elements will have an influence on both the sensory perception, but also the oral processing in terms of how fast we eat, for instance. And I will give further details on this in the next slides. So in the design of snacks, we can first of all play with the composition and microstructure. The composition will, of course, influence both taste and texture perception. So an example here, we have recently worked on the concept of decoupling texture from nutritional composition and energy density. So as an example, we were able to reduce sugar and fat by 30% in a cake formulation, while maintaining or even enhancing liking by matching or actually enhancing positive attributes like perceived moistness, softness, and also sweetness, despite the sugar reduction. So that means that smart formulation choices can be made, which will control sensory perception and consequently also oral processing and eating rate. Next, formulation and processing choices will also affect microstructure, which links again to texture perception and hence also affects eating rate. Morphology and food dimensions are another way of controlling texture and hence modulating eating rate. So for instance, in the picture that you see here on the right, you can see biscuits which were designed with varying the distribution of the solid phase and the voids, which in turn affects the overall density of the snack. These changes will affect the hardness, which in turn will influence then the breakdown and the eating rate of the snack. Here you can already see that by playing then with the morphology in combination with the formulation and microstructure of the solid phase, which I presented in the previous slides, then this already will provide multiple opportunities to modulate sensory perception and also eating rate. And finally, the distribution of components in a composite food, like for instance, a hard and crispy component together with a soft and creamy filling, will also affect the sensory perception in terms of texture and taste, and consequently oral processing and eating rate. For instance, in the example that you see on top, you see a biscuit with a chocolate cream, which is always added in the same amount, but with different patterns of distribution. And you can also see from the table that the liking is actually not affected, while the hardness perception is significantly different depending on how the filling is distributed. And this will also have an effect on the eating rate. Also, for instance, in a recent work that we did together with Duerke, we also showed that in bread with addition of a spread like margarine, when you play with the thickness of the bread slice and also with the amount of margarine that you add, you can already affect significantly the texture perception, and also consequently you modulate the eating rate.
From all these insights in food structure related to oral processing and sensory perception, we came to the following approach. The proposed approach consists of 3 work packages. The first one is about food texture design, which include the texture design tools presented by Stefano. After that, we will do some sensory and oral processing experiments. And the last work package consists of real snacking behavior. Now this slide summarizes all the proposed methods. For food formulation, we will use innovative and traditional processes to design model foods with varying microstructure, morphology, and mechanical properties. For sensory measures, we will use the dynamic sensations to get insight in the sensory perception over time. And we will measure the liking, and we will do that for 1 bite and also for more bites. For oral processing, we will measure chewing behavior, bite sizes, and the eating rate. And of course, we will link this to the sensory perception as well. Then we will measure the real snacking behavior. We will measure ad libitum food intake, dynamic changes in hunger and pleasantness over time. And if the budget allows, we can also use a snack box. That is a device that people can take home. They can put the snack on and it will record the consumption pattern over, for example, over a day. So that is in a more realistic setting. So structures and foods of interest. Well, first of all, we are also open and interested in suggestions that you may have. We were thinking of using maybe heterogeneous textures, for example, with coatings or something with a soft inside, crispy outside. We also worked in the past on composite foods. We worked on bread, thickness in combination with condiment addition, and there we also found very clear effects on the eating rate. So it would be also interesting to study this further in, for example, snacks with sauces or condiments. We are also open to use cereals or cereals bars or snacks in smaller bites. So I think there are a lot of possibilities in this project. And if you have a different idea, yeah, we would like to know. So the intended project results and deliverables, what I also told in the beginning, the figure below, it is really about understanding all these steps from structure to our processing, flavor, liking, and food intake. Yeah, to be more clear, we want to understand how food formulation and food structure can be used to prolong the eating rate. We want to understand how food structure can be used to vary the flavor and texture sensations dynamically. We want to predict the overall palatability of the food by identifying the most optimal dynamic combinations of sensory attributes. And the most important aim is, deliverable is to develop design rules that moderate intake without compromising on consumers' acceptance and reward. Well, thank you for watching this video. We are very curious what your ideas are, and we are looking forward to discuss further over foods of interest or concepts of interest. Yeah, what do you like about the approach, or is there something that you miss, or do you have any suggestions? We are open to hear this. Bye bye.